Since 1950, more architects have used concrete with greater freedom and imagination than in all the previous 100 years. But it is only fair to suggest that today's architects have more going for them than their fathers. In addition to a sound, controllable basic material, major developments in structural design and new methods of fabrication and construction have made concrete a material of unlimited architectural forms and shapes, easy and economical to use. The greatest noticeable change in today's architecture has been the wide use of surface-resistant structures, thin slabs of concrete which, when curved, folded, or bent to achieve structural strength, also produce novel and exciting aesthetic forms. These shapes are recognizable as single or double curved barrels, slabs folded into a profile of gables, blunted into hip slabs, interrupted in sawtooth arrangement, or both folded and curved to produce domes. There are double curved forms of rotational domes, cones which produce partial roof structures, or entirely enclosed conical walls of multi-story structures. And finally, hyperbolic paraboloids, double curved slabs which can be used as louvers in long screen walls, joined in multiple units as roofs or canopies, erected as freestanding cantilevers of exciting thinness and grace, or employed singly as self-supporting saddle structures. Perfection of pre-stressing design and methods now permit prefabrication of tall vertical and long horizontal framing members and floor and roofing members, which can be quickly assembled on the job without cumbersome and costly false work. Such pre-stressed units permit longer spans, less dead load, and reduction in volume of materials needed. Precasting, or plant fabrication of concrete, is fast developing into an industry capable of supplying reinforced and pre-stressed concrete structural members of any shape or form. But the growing precast industry's greatest boon to decorated concrete is the manufacture of curtain wall panels in an unlimited variety of sizes, shapes, thicknesses, textures, and colors. These are produced by molding against textured form liners. By exposing aggregates to reveal natural colors. Use of mineral pigments in white cement matrices. Piercing to produce screen or grill panels. And sculptured details cast against rough sand molds. Refinements in fabrication and imaginative handling in design and erection have also changed the concrete block from a plain but useful backup material into an exposed medium in which color, texture, and sculptural effects offer unlimited possibilities. New products and equipment which have made site operations faster and more economical in the past dozen years include pre-molded, warpless forms of plastic which may be reused many times without damage. Synchronized hydraulic lifts, which permit roofs and floors to be cast on the ground and then elevated into place. And climbing cranes with 360-degree swing, used on central concrete support and service area cores to handle materials and equipment during construction of floors and walls of tall buildings. On large buildings, shell structures are usually confined to roofs or floors supported by high columns or frames. For the new Memphis airport, the architects chose a series of 40 inverted hyperbolic paraboloid umbrellas on tall columns as both roof and weather canopy. All lights are concealed within the offsets below each shell. of long-hipped plates, supported only at their ends, produce a spacious, open interior for the new St. Paul, Minneapolis International Air Terminal. A running series of inverted hyperbolic paraboloids form a canopy over entrance and departure ramps fronting the building. An undulating row of long concrete barrels roofs the new library at Texas Tech, sheltering broad interiors handsomely finished with a variety of precast concrete panels. When the ends of barrels or folded plates used as roofs are left open, as they often are, they provide for wide panels of high, clear-story glazing, attractively framed by the shape of the shells. The entire main facade of the new Lubbock, Texas municipal building is glass, descending from the folded slab roof. Some types of buildings may be dominated or entirely enclosed by shell structures. An example is the Flying Carpet Motel near Chicago, whose lobby and office structure is an arrangement of steep-sided folded plates. The Osborne Radio Center at Tulsa, Oklahoma is a similar arrangement, but uses intersecting double-curved barrels. The soaring, exciting hyperbolic paraboloid saddle shell, supported on the ground at 2 points only, is a structural feature which determines the architectural design. It forms the entire roof of the Cheyenne, Wyoming Air Terminal. The largest saddle shell built to date in America spans 221 feet over the columnless interior of the 1,350-seat Eden's Theater, Northbrook, Illinois. The 4-inch thick shell with its gradually thickened edge ribs is tied to massive pre-stressed ground supports. The walls are glass and precast concrete panels. Until a dozen years ago, you could always tell a church or temple by its Roman or lancet arch windows, Gothic finials, and steep spire with a bell lantern. These medieval details have been banished by the new shapes in concrete, and the only religious symbols left are the Christian cross and the Hebrew Star of David. And these are sometimes deftly worked into the structure of the buildings, such as the Chapel of the Holy Cross at Sedonia, Arizona. This simple, almost austere structure in its desert mountain setting is really a large, single-hipped, folded plate. Its thin, slanting sides and rear sloping roof are stiffened by vertical and horizontal concrete braces forming the cross. The bottom edges of the triangulated folded slabs forming the roof of Temple Israel in St. Louis also form the 6-pointed Star of David in a beautifully simple coffered ceiling. In St. Petersburg, Florida, the sharp angles of the semicircular folded slab roof of B'nai Israel Temple are repeated in a large, open, precast concrete screen wall, which includes a dozen or more overlapping 6-pointed stars. Walls, floors, and folded roof of St. Mary's Church, Cecil, Pennsylvania, were all precast in the shop and carted to the site for erection. Crosses, molded with the triangulated roof members, connect the plates at the ridge. The simple geometric shape of the building gives the impression of a cut jewel in its rolling green-wooded setting. A more complicated triangular arrangement of folded slabs form both roof and walls of Gustavus Adolphus Church in Minneapolis. The interlocking wall triangles are separated by narrow slabs of stained glass. Trinity Lutheran Church, near Minneapolis, also has interfolded slab roof and walls, the latter dropping as single inverted triangles to permit large areas of colored slab glass to be bound together in abstract patterns by a matrix of concrete mortar. The thin, graceful, soaring roof of St. Edmund's Church in Milwaukee was the first use of the hyperbolic paraboloid form in the Midwest. This saddle shell, requiring no bearing walls, was modestly enclosed to achieve one of the least expensive church structures and one of the most successful architecturally. A cluster of inverted hyperbolic paraboloid units bent upward to suggest an attitude of hands lifted in prayer formed the roof of the new Presbyterian Church, Mercer Island, Washington. All four walls under this graceful canopy are of glass. 6 long concrete barrels fronting on 2 facades of Immaculate Conception Church in Pittsburgh are reduced in diameter as they converge over the altar. The wall ends of the barrels are decorated with huge panels of colored slab glass in molded concrete patterns. A series of exposed, 3-hinged concrete rigid frame vents form the structure of the second Presbyterian Church, Fort Lauderdale, Florida. The front facade is a cast-in-place concrete screen pierced by many free-form openings which are enclosed with cathedral glass. A plain concrete slab roof for the little chapel at Our Lady of Florida Monastery and Retreat at Palm Beach, Florida, is supported on slim, double-tapered columns. The enclosing walls are a checkered pattern of solid and pierced concrete panels which give high color to a modest interior. The cross, as a symbol, is developed out of the structural need for exterior column supports for overhangs and balconies around the cloistered courtyards of other monastery and retreat buildings. The curved and slightly twisted surfaces of the cruciform columns produce a moving, sculptured effect. The single, very lonely barrel element of Temple Mount Sinai in El Paso, Texas, is a truncated cone located near the end of a long, low, austerely plain concrete slab building housing the congregation. Its setting, as bleak and barren as the Sinai Desert for which it's named, must be considered a strong component of the architectural scheme of the building. Concrete shells have changed schools to such delightful ideas as Vista Mar School near San Francisco. A full circle of classrooms is roofed by pie-shaped folded plates which cantilever to form a weather canopy around the interior walkway. North Mercer Junior High School near Seattle is a charming patch of toadstools made of hyperbolic paraboloid umbrellas at different elevations. Vertical spaces between shell units provide for clear-story light panes which illuminate from all directions. 20 years ago, precast concrete, then called cast stone, was used principally as decorative trim. Cornices, sills, lintels, plaques, cartouches, and cornerstones for brick buildings. Today, it is used widely for a variety of structural, enclosing, and finish purposes that range from the many hexagonal and triangular trusses welded together to form the bones of 3 large glass-enclosed domes at Mitchell Park Horticultural Conservatory in Milwaukee, to the towering octagon of New York's new Pan Am building, which is enclosed with 9,000 gleaming white exposed aggregate panels. Story-high concrete frames were used for the picture window openings of Detroit's new Bank and Trust building. 8 by 14-foot solid panels of exposed aggregate concrete in harlequin patterns of contrasting colors sheathe 3 upper stories of a Chicago shopping center building, while gray-green exposed aggregate panels as thin as 3 inches and as long as 24 feet were used for spandrel walls of grand apartments in Des Moines, Iowa. Both solid exposed aggregate panels and grille units form the walls of the new Madison Heights building in Memphis, Tennessee, whose courtway owns a graceful stairway made of precast, pre-stressed concrete. The predominantly glass walls of Republic Savings and Loan Building are shielded from the hard Dallas, Texas sun by a continuous screen of grille units. Precast curtain walls are especially useful for curvilinear structures because they can be easily articulated at vertical joints of large units, or by the piece in small units, such as these sculptured grille blocks used as a screen for this law office building in Miami, Florida. The circular sunscreen encloses a concrete frame office building fully glazed along its outside walls and around the balconies of the interior court. The concave main facade of the Modern Medicine Publishing Company near Minneapolis gently curves around a lagoon, a double solution for a sight problem and the desire for a graceful but long, narrow structure in which all offices have maximum privacy and maximum natural illumination. The concrete frame is hung with exposed aggregate panels. A huge ring of concrete on stilts provides scores of well-lighted offices for the headquarters of the North American Baptist Convention at Valley Forge, just outside Philadelphia. The concrete frame is enclosed with many sizes of precast panels made of glittering white quartz, exposed in a white cement matrix. Some massive pylons which relieve the monotony of an uninterrupted ring are of split block masonry units made of the same white materials. The surprising serpentine walls of Philadelphia's new police headquarters are probably the top example to date of the nearly unlimited possibilities of precast concrete. Except for a spine of cast-in-place columns which anchor inner edges of the wedge-shaped floor slabs, all structural and enclosing members are precast concrete, and all 2,000 pieces interact to carry the load of the structure. The 3-story high, 5-foot wide curtain walls, supported on precast units cantilevered 12 feet out from the base columns and tied to the first floor slab by pre-stressing, are load-bearing. They support the outer ends of all floor and roof slabs. Exposed surfaces are made of white quartz, white sand, and white Portland cement. The 3, 15, 18, and 21-story circular dormitories at the University of Pittsburgh are concrete structural frames built around pre-erected service corps. They are enclosed by precast columns facing units and curtain walls. But the most spectacular core project to date, the tallest apartments in the world and the highest reinforced concrete structure in America, is Chicago's Marina City. Its twin 600-foot-high cylindrical cores, topped by climbing cranes, leaped skyward 3 floors at a time, while the helical ramps of the garage areas and pie-shaped apartment floors followed along. Cast in place in plastic-lined forms, the sturdy exterior columns are concealed by the overhanging scalloped balconies. With windows and railings located well behind the balcony edges, the towers retain the fascinating lines and forms of their structure, which in most buildings are covered up or distorted by the finishing trades. It is widely conceded that many European and Latin American architects and engineers are bolder in their use of concrete than their American brothers. However, recently completed U.S. projects by 3 world-famous designers failed to overshadow the brilliance and novelty of much of their work at home. And only one structure is likely to raise much controversy. But they are notable contributions to the visible revolution in American architecture. St. Patrick's Church, Oklahoma City, is the design of Felix Candela, the Spanish-born Mexican master of thin shells. Indeed, the rectangular roof is a grouping of inverted hyperbolic paraboloids left unfinished to reveal their rough texture. Probably the most pleasing and unusual feature is the solid concrete panels with vigorous sculptured detail, which were cast flat on the ground by volunteer labor in the parish and tilted into position as freestanding walls. Natural illumination comes from the space between wall tops and roof edge. Rain can fall through these spaces too and be rushed away from the auditorium floor by gutters and drains. Although the great, thin, long barrel of Pier Luigi Nervi's Dartmouth College field house is far more graceful than the cumbersome barrels erected over arenas and exhibition halls in America in the 1930s, it suggests little of the lacy magic of Nervi's sport palaces in Italy. When the interior is completed, however, it will reveal more of the familiar details of the world's premier engineer, designer, builder. The open work usually found in Nervi's barrels and domes is confined to the framing of the strong trusses which support the diamond-paneled roof of New York City's new bus terminal. The structural and architectural scheme of the multi-deck structure is brilliantly planned as visual extension of the George Washington Bridge onto which it opens. This striking functional layout was entirely cast in place with such care that almost perfectly smooth concrete surfaces were produced. Although the the fractious Swiss-French genius, Le Corbusier has been collaborator, consultant, or critic on numerous American architectural projects. The new Visual Arts Center at Harvard is his first solo performance here. It is not as way out or offbeat in form, texture, and use of space as his French or recent India buildings, but it is so nearly full-blooded Corbusier that this odd-shaped, rough-finished concrete structure, flunked in the middle of Harvard's traditional layout, is bound to raise eyebrows and voices. Familiar Corbusier touches are windows oriented against the sun and walls working as sun screens, used heretofore on his projects in the tropics, but likely to prove friendly when things get hot in Cambridge. Location of the main entrance halfway up the building is a sharp break with conventional building layout. But it is made acceptable by Corbusier's graceful use of a long, curved ramp. It is a characteristic use of a structural feature to produce spatial, sculptured effects in modern concrete.